Okay. We're going on with exponential simplification of exponents, where in fractions, okay, it's multiplication, right? Okay. And with multiplication, so first of all, the key thing to note is that everything here in the top and the bottom, the operation is multiplication. So the first thing is you have to get your bases to be prime numbers. Remember, what's a base? A base is something with an exponent on top of it. So your first base that you've got to get to prime powers is 9. So 9 is going to become 3 squared to the x. Okay, 5 is already a prime number, so it's times 5 to the 2x. Okay, here 3 is already prime, so it's 2x plus 3. And here 25 will become 5 squared to the x. Okay, then I'm going to use the rule am to the n is equal to a to the m times n in order to do this one over here and this one over here. So it becomes 3 times 3 to the 2x times 5 to the 2x over 3 to the 2x plus 3 times 5 to the 2x. Okay. Right. Then, okay, because everything's multiplication, I can move everything to the top. I will normally skip this step and go straight to the next step. Okay, but these all stay at the top. So it stays positive exponent. Exponents don't change. But then I'm going to move these powers in the denominator up because the operation is multiplication, because there are no plus and minus signs. And when I move those up, it's going to become 2x plus 3 changes to negative 2x minus 3, and 2x changes to negative 2x, right? You can also, as I say, go straight to this step over here, where you simply do combine the two steps together, and you go 3 to the 1 plus 2x. Okay, I'm doing all the threes. There's a 3, there's a 3. Okay, sorry, I lost concentration, sorry. 3 to the minus 2x minus 3. If I go back, that became times 5 to the negative 2x. Okay, so I end up with, I look at all the threes. Okay, here all the threes over here, and I add the exponents. I get 1 plus 2x minus 2x minus 3. And if I look at the fives, it becomes times 2x minus 2x. So you can go straight from there to there, where you get the fives, and you go 5 to the 2x minus 2x. Okay, and you get the threes, and you go 3 to the 1 plus 2x, but this is at the bottom, and when it moves up, it becomes minus 2x minus 3. Then it's simply a case of adding your exponents. So you get 3 to 1 minus 3 is negative 2, and times 5 to the 0. And we simplify that. 3 to the negative 2 becomes 1 over 3 squared. So you get 1 over 3 squared times 1, which is simply, your final answer is 1 over 9. So it's multiplication, get your bases to prime, move things up. When you move powers up, the signs of the exponents change. Okay, get that, pause and get that down if you haven't yet. Okay, right, the next one, again, first thing to check is everything multiplication. So everything is multiplication in the numerator and the denominator. So your first step is to get all your bases to be prime. So 8 is going to become 2 to the 3 to the n. 6 is going to become times 2 times 3 to the n minus 3. Okay? 9 is going to become times 3 squared, okay, to the 1 minus n. Right, then in the denominator, remember 16 as a prime is not 4 squared, it's 2 to the power of 4. So you get 2 to the 4 to the n minus 1. And 3 stays 3 to the negative n. Okay, now you're going to raise, remember there's a silent one here and here. Raise your powers to other powers. So 3 multiply the exponents, I get 2 to the 3n. Over here, remember, one has to go into distributing one throughout that, so it's going to be times 2 to the n minus 3. And I do the same thing with this 3 to the 1. So it'll be times 3 to the n minus 3. And then here, I'm multiplying the 2, distributing the 2 there. So 2 times 1 minus n gives us 3 to the 2 minus 2n. At the bottom, okay. Over here, we've got 4 times n minus 1, which becomes 2 to the 4n minus 4, and then times 3 to the negative n. Right, I'm going to skip out a step here. Okay, what essentially I'm doing is moving the denominator, the powers in the denominator up, and when I do that, the sign of the exponents of those things at the bottom will change. But I'm going to do everything in one step. And so what I'm going to do is I'm going to look at all the base 2s. So there's a base 2, there's a base 2, here's a base 2, there's my 3 base 2s. And when you multiply them, you'll add the exponents. So it's going to be 2 to the, this is going to stay as 3n. Okay. This is going to stay as n minus 3 because it's still at the top. These are going to change signs. So when I move that up, okay, sorry, it's going to become 2 to the 3n. This is going to stay the same, so it's going to be plus n minus 3. Okay, this is going to move up, so it's going to become minus 4n plus 4. Okay, I've moved those powers to the top, so these have changed signs. Then I look at the things with base 2. With base 3, so those are all base 3. So it's going to be times 3 to that. That stays at the top, so it stays n minus 3. Okay, that stays at the top, so it stays, the signs stay the same, so it's going to be plus 2, okay, minus 2n. Okay, this moves up, so it's going to become minus 4n plus 4. Right. Okay, when things move up, the sign of the exponents change. Now I go to the base 2, so I add like terms. 3n, 4n, those disappear. Minus 3 plus 4 is 1. So I'm left with 2 to the 1 times here. I'm going to have n minus 2n is negative n. Okay, negative n minus 4n is going to be negative 5n. Okay, then I'm going to have minus 3 plus 2 is negative 1. Negative 1 plus 4 is negative 3. So negative 3, negative 1 plus 4. Okay, sorry, negative 3 plus 2 is negative 1. Negative 1 plus 4 is 3. Okay, so I get 2. Okay, so double check that for you. That works. Yep. That 3's n minus 3, 2 minus 2n. Okay. Minus 1 plus 4. If I add like terms, negative n minus 4 is negative 5n. Minus 3 plus 2 is negative 1 plus 4 is 3. So that's it. So actually, there's nothing else you can really do. And you're going to leave that as your final answer. Okay. Not a very pretty answer unless I'm double checking. I haven't made mistakes. I hope I haven't made any mistakes. Okay. 2 to 3n. Okay. Plus n minus 3. Looks right to me. Okay. 3. No, man, I'm an idiot. Come on, Roger, be better. Okay. This. Okay. I was looking at the 3's. Okay. It's n minus 3 plus 2 minus 2n. And this one moved up. Okay. So when I moved that one up, it should have been plus n. Okay. So the 2's are correct. Okay. But the 3's will be n, 2n minus 2n disappears, minus 3 plus 2 is minus 1. So it'll be times 3 to the minus 1, which will become 2 times 1 over 3, which is 2 over 3. Okay, that looks better. So I kept double checking. That one didn't look very nice. All right, so that is your multiplication processes. Okay, make sure you got those down. Okay, now we move into a slightly different section. Okay, And we kind of normally up to now, we said that a to the x times a to the y is a to the x plus y, and we've gone in that direction. Okay, but likewise, you can go in that direction and rewrite a to the x plus y as a to the x times a to the y. And normally we've gone like that and said a to the x times a to the negative y is a to the x minus y. Okay, but likewise, a to the x minus y can be written as a to the x times a to the negative y. And we're going to use that logic in order to factorize. Remember, factorize means rewrite something as something times something. So we're going to try to factorize these expressions over here. Okay. So to do that, well, I don't have a problem with this initial first term. Okay. I'm going to apply this rule over here to this term over there. So that's not going to change. It's going to be 5 times 2 to the x. But this 2 to the x plus 2, if I use this rule over here on that, it can be written as minus 2 to the x plus 2 is the same thing as 2 to the x times 2 squared. Remember, if you multiplied these two things together, you'd get back to that over there. Now, I have two terms in this expression. Okay, I'm trying to factorize it. So there's a common factor, okay, in this expression of 2 to the x in both cases. Normally, it's the power with a variable as an exponent that you take out. So I take out 2 to the x. So step 2 actually should go down here. Okay, that was step 1 done. Step 2 says take out the common factor. Okay, so the common factor is 2 to the x. What do I have to times 2 to the x by to get back to that term? By 5. Then I've got a minus sign in between over here. So it becomes minus. What am I left with in this circle? 2 squared. Okay, and if I simplify the brackets, the thing in brackets, it's 2 to the x. Well, 5 minus 2 squared is 5 minus 4, which is 1. So it just simplifies to 2 to the x. So when you're adding and subtracting, this process of factorizing by first doing that split over there is a really useful tool. The difference is with these ones is you're adding. The ones we did before, everything was multiplication. Okay. So if I look at this one over here, remember, always first get your bases as prime numbers. Okay. So, well, the 2 is already prime, but I'm going to rewrite this using that rule I just talked about as 2 to the 2x. I only do this because there's an adding thing here. Otherwise, I would not do this. So you're going to get 2 to the 2x times 2 to the minus 1. 4 I'm going to write as base 2. So then I've got the plus sign. 4 becomes 2 squared to the x plus 1. Okay. This is not going to change over here. That's still going to be 2 to the 2x times 2 to the negative 1. Here, I'm going to first distribute that. So it's going to plus 2 to the 2x, okay, plus 2. Now, because I'm adding, and I'm going to try to factorize, I'm going to split this bit up over here. So this is going to stay at 2 to the 2x times 2 to the negative 1. Okay. But this I'm going to rewrite because I want to factorize it, and the instruction is adding as 2 to the x times 2 squared. So now I have two terms, they're separated by a plus sign. And what's the common factor? The common factor is 2 to the 2x. So I take out 2 to the 2x as a common factor. What I have to times 2 to the x by to get back to that term? By 2 to the negative 1. Then I've got a plus sign. And to get back to that term, by 2 squared. Okay, so I've factorized. Now I want to simplify the numerical part within the bracket. You can actually just cheat and use your calculator. So you're going to end up with 2 to the 2x. If you stick that into your calculator, you're going to get a half plus 4. A half plus 4 is a half plus 8 over 2, which is going to be 9 over 2. So there's, I've written that as a single term. There's no plus or minus signs in between. Okay. Right, get that down. Right, and the next one, you've got 4 times 3 to the 1 minus x. So now there's a big note there that 4 is not a base. So you don't have to worry. I mean, you could change 4 to 2 squared, but you really don't have to worry about that. Okay, so I'm going to leave that 4 over here just as 4. there's a plus sign, so I want to split these up and factorize it. So 3 to the 1 minus x, okay, is going to be written as 3 to the 1 times 3 to the minus x. Then I've got a plus sign over here, okay, and then 3 to the 2 minus x, I'm going to rewrite as 3 squared times, okay, 3 to the 1 times 3 to the minus x, this should have been, okay, 4 times 3 to the 1 times 3 to the minus x, plus 3 squared times 3 to the minus x. Now you've got two terms in this expression, okay? You're really interested in taking out the power which has a variable that's an exponent, which in this case is 3 to the negative x. So if I take out 3 to the negative x from this term over here, I'm still left with 4 times 3 to the 1. And I've taken out 3 to the negative x. Then I've got a plus sign over here. Okay, and then I'm left with 3 squared because I've removed the 3 to the negative x. Okay, and if I simplify the numerical parts, I'm left with 3 to the negative x. 4 times 3 is 12. 12 plus 9. So you get 3 to the negative x times 21. Okay. Right, so that's just practicing factorizing. When do I do that? When I'm adding terms in order to simplify them. But it becomes really useful when I do the next thing over here, which is fractions. Okay. Right, where you've got more than one term in either the numerator or the denominator. Okay. Then what you're going to do is factorize what you've been practicing now, okay, and take out, okay, the 2 to the thing with the variable as the exponent, cancel that, and then simplify the brackets. So what the hell am I talking about? Well, we're going to factorize, first of all, this top bit over here. So 2 to the x plus 2, in order to factorize, I'm going to rewrite as 2 to the x times 2 squared. Okay, then I've got this minus sign over here. And 2 to the x plus 3, I'm going to write as 2 to the x, okay, times 2 cubed. You notice how this is completely different from the first bit we did, which was all multiplication. Completely different technique. So you really have to spot these plus or minuses. Then over here, 2 to the x plus 1, I'm going to write as 2 to the x times 2 to the 1. Okay, then I'm going to have a minus sign. 2 to the x plus 2, I'm going to write as 2 to the x times 2 squared. Okay. I do that because I want to factorize. Okay, so in the numerator, I've got two terms. I want to take out the thing which has a letter, okay, as an exponent. So I'm going to take out 2 to the x to get back to this term over here. Okay, I've taken out the 2 to the x. I'm left with the 2 squared. Then I've got this minus sign over here. Okay, I've taken out the 2 to the x. What am I left with there? I'm left with 2 cubed. Okay. In the denominator, I've also got two terms. I always circle my terms. I'm going to take out 2 to the x as a common factor. What am I left with here? I'm left with 2 to the 1. Then I've got this minus sign over here. Okay, taking out the 2 to the x, I'm left with 2 squared. Now, at the top, I read there's something times something, and the bottom is something times something. If your instruction at the top is multiplication, we can cancel, so we can cancel those. You can now go cheat and use your calculator if you hate doing this manually. Okay, but if you do it in your head, you're going to get 4 minus 8, which is minus 4. And here you're going to have 2 minus 4, which is minus 2. So you get minus 4 over minus 2, which is 2. Okay, so when it's multiplication, when it's more than one term in the numerator or the denominator, you have to factorize, cancel the power which has a variable as an exponent, and then simplify using your calculator or your brain. Okay. Right, so here, what do you look out for? Okay, you look out that this plus sign should send off alarm bells. That tells you you're going to have to factorize. In order to factorize, you're going to have to rewrite 3 to the x plus 3 and 3 to the x minus 3. And because you want to cancel the 3 to the x's, you're also going to rewrite that as 3 to the x times 3 to the minus 2. Right, so I want you to try to do this on your own and then press pause, okay, and then check that your answer is the same as mine. Right. So now I've got 2 times 3 to the x plus 2. I'm going to write as 3 to the x times 3 squared. Then I've got this plus sign. Okay, and then 3 to the x minus 3. I'm going to write as 3 to the x times 3 to the minus 3. At the bottom, I've got 5 times 3 to the x minus 2. I'm going to write as 3 to the x times 3 to the minus 2. Okay. Right, I want to factorize the top, and I've got two terms. I always want to take out the letter as the exponent, so I'm going to take out 3 to the x. What I have to times by to get back to that circle, that term, I'm left with 2 times 3 squared there. Then I've got this plus sign over here. And then to get back to this term over here, I've taken out the 3 to the x, so I'm just left with the 3 to the minus 3. Okay? And then at the bottom, I'm just going to leave it like that, because that's factorized already because everything's times. Okay? So the top I read as 3 to the x times that, and the bottom is just times. So the instructions are multiplication, so I can cancel those 3 to the x's. Can use your calculator to simplify this bit over here. It's going to be 2 plus 9 plus 1 over 27. Besides, we've got on my head, I'm going to do it on my calculator. Even if there's no calculator, I'm going to use the calculator. So I've got 2 times 9, which is 18, plus 1 over 27 equals that, divided by 5 times 1 over 9. Okay, and if my calculations are correct, I got, you have to check my working over there. Okay, you're going to have 2, can't see here, sorry, 2 times 9, which is 18, so it's 18 plus 3 to the negative 3 divided by 5. Yeah, it's a horrible number. Okay, so you get 32 and 7/15, which is the same thing as 15 times 32 equals that, which is the same thing as 480 over 15. Okay. Which could simplify some more. Right. All right, so that's your answer for B over there. Right. So now I want you to go try do on the next page. Is there a next page? Yeah. Okay. I want you to go try to see on your own quickly, and come back and look at the answer. But try it yourself first. All right, so for C, okay, you're going to have to factorize because there's a plus sign. So you're going to have to make 9 base 3, so it'll become 3 squared to the x. Okay, then you've got the plus sign. 3 to the 2x plus 1, you're going to rewrite as 3 to the 2x times 3 to the 1. 18 is a base, so you're going to have to make it prime, so it'll be 9 times 2, which is 3 squared times 2, all to the x. Okay, right, times 2 to the 1 minus x. This looks like a bit of a sneaky question. That's what is going on here. So times 2 times 2 to the negative x. I hope I copied this question down correctly. Okay, so let's see what happens. Right, so I just stick to my rules. 3 to the 2 becomes 3 to the 2x. Okay, plus 3 to the 2x times 3 to the 1. The bottom here, I'm going to have, if I distribute that, I'm going to have 3 to the 2x times 2 to the x times 2, okay, times 2 to the negative x. So now we've got to think a little bit with this one. Well, the top, there's really only one thing we can do, okay, and that's take out 3 to the 2x as a common factor. But to get back to this term, you've got to times by 1, plus to get back to this term over here, just don't do that, you've got to times okay, you've got to times by 3. Okay. Here, remember 2 to the x times 2 to the negative x. You add the exponents, you get 2 to the x minus x, which is 2 to the 0, which is just 1. So these essentially cancel each other out. and you're left with 3 to the 2x in the denominator, okay, as well as times that 2 over there. Then the 3 to the 2x's cancel out, so I'm left with 4 over 2, which is equal to 2. I was doing that. Okay. Sorry about the crossing out. I don't know what the hell happened there. Okay, so your answer is equal to 2. Right, last one for today. Okay, well, you want to factorize. Okay, so you take the smaller power and you leave it the same. 2010, okay, to see if this makes sense to you, is this 5 to the 2010 is the same thing as 5 to the 3. By the way, if you put those in your calculator, the calculator will have a nervous breakdown. So you'll have 5 to the 3. Now, what I have to add to 3 to get back to 2010, I've got to add 2007. So I really forced 5 to the 2007 into that whole thing over there. I recognized if I want to take out 5 to the 2007 as a common factor, I've got to rewrite the bigger one as 2007 times 5 to the 3. So at the bottom, okay, I'm going to do a similar thing. I'm going to take out the smallest, okay, I'm going to leave the smallest power as it is. But 2009, okay, I'm going to write as, I want to force 2008 into that. So it'll be 5 to the 2008 times 5 to the 1. So when I add them, I get 2009. Now at the top, there are two terms. There's a common factor of 5 to the 2007. Okay, what I have to times 5 to the 2007 by to get back to itself, I've got to times it by 1. Okay, then I've got this plus sign over here. Okay, and then what I have to times, yeah, I've taken out 5 to the 2007, so I'm left with 5 cubed. At the bottom, I've got a common factor of 5 to the 2008 in both terms. To get back to itself, I've got to times by 1. Okay, then I've got this plus sign. And then to get back to this term over here, I've still got that 5 left over there. Okay, so now 5 to the 2007 over 5 to the 2008 leaves you with one more power of 5 at the bottom. So that becomes 1 over 5 to the 1. Okay, right? And in the brackets, that's 1 over 5 to the 1. And in the brackets, just 1 over 5, I'm left with 1 plus 5 cubed, which is 126 over 6. And if you put that into your calculator, okay, it's going to be, calculator's a funny mode. It's going to be 126 divided by 30, which gives you 4 1/5, which is 21 over 5. Gives you a final answer. All right, guys. Okay. Thank you very much.